And we're live. Hello and welcome everybody to the next session of our journey of Python. We've been learning Python by doing these live streams where we look at the official documentation for Python, learn from it, and we try out things ourselves and learn from that as well. Okay, so that's been the way we've been approaching this. We've had a few streams already. This is stream number 6. We have 5 streams already, and you want to check out, if you're new here, you want to check out the older streams, go to the link in the description. There's a playlist covers, which has a list of all the streams that have happened so far. The goal of these streams is to cover Python, learn Python completely from the scratch as a Java developer. I consider myself a Java developer. I'm not a Python developer. I am learning Python live, and I invite you to join me as we learn Python together. Everything that I do in Python is live and recorded on the stream. Okay, so there's no like, I don't prepare, I don't have like exercises, like everything that I do is on the stream. So you're not going to miss out on anything. It's an opportunity for me to share how I learn. I would love to hear how you folks learn as well, so that we can compare and learn from each other about learning. And it's also an opportunity for us to learn Python together. We have covered a lot with Python. We've looked at the basic syntax. We've looked at the data structures. We've looked at modules. We've looked at packages, input output, file manipulation, and now we are looking at object oriented programming in Python. Last session we learned about classes. We did some sample exercises. We learned about classes. And now we're going to be moving on to inheritance. This is where we stopped last time. Okay, so this is where we stopped. And we're going to learn about inheritance and onwards today. The code is in a repo that I'm going to, let me see if I can paste this here. It's on GitHub, and I will be posting uh, updates as I work here, like as I make changes to the code, as I try out new things. I will be pushing those changes to this repo, and you should be able to pull that. I just posted that in the chat as well. The environment that we're using for working on Python, we're not installing Python on our local machine. What I have here is a Docker instance, right? It's a Docker VM running Python. So here I have Docker running, and I'm using VS Code to connect to that Docker instance. So what you're seeing here is basically my Docker instance, like it's Linux, which is running um, Python. Okay, it has the Python environment. It has the Python environment set up, and it's doing that here. I'm going to change. Wait, it doesn't exist here. I'm going to change the prompt because this one's a little too long and I don't like it. Okay, this is better. The code has 2 folders. One is the exercises folder where we try out an exercise. We have been asking ChatGPT for exercises. It's been pretty good at giving us, okay, do this and then do that. We haven't asked it for solutions. We have asked it for problems. So we get a problem from ChatGPT and we implement it, and then we ask ChatGPT for another problem. So these are some of the problems that we've done so far, starting from the very basic greeting message to operations, guessing a number game, word count, you know, using a calculator, and a diary utility, which basically allows you to write diary entries and then um, save it to a file and read from it. Yes, Java does support text blocks. For the longest time it didn't, but you're right, it does support text blocks. And I saw your comment as well. I'll try to make a tutorial on that for sure. Okay, so let's continue on with our journey of um, Python object oriented programming. And we left off at inheritance. Of course, a language feature wouldn't be worthy of the name class without supporting inheritance. The syntax for a derived class definition looks like this, right? It's not an inherited class or not a child class. It seems to be a derived class. Derived class name, and then you pass the base class as an argument. So it's almost like a method, right? But it's with a class keyword, and it's extending from a base class. You can extend a class into another class, and then you can add statements inside it of its own. The name base class must be defined in a scope containing the derived class definition. In place of a base class, other arbitrary expressions are also allowed. This can be useful, for example, when the base class is defined in another module. Ah, okay, okay. So it looks like what we are passing here is the object, the class object, because that's what you're getting over here, right? When you do mod name dot base class name, you're getting a class object. We can experiment with that when we write this out. I want to create a class, assign it to a variable, and then pass that variable, and we'll see if that works. Um, well, no, not exactly. We're not passing the variable here. You're just using it. You're kind of having a reference to that right there. Hmm. We will see. We will see. Um, Execution of a derived class definition proceeds the same as for a base class. When a class object is constructed, the base class is remembered. It is useful for resolving attribute references. If a requested attribute is not found in the class, the search proceeds to look in the base class. The rule is applied recursively if the base class itself is derived from some other class. Again, very similar to Java inheritance. There's nothing special about instantiation of derived classes. Derived class name creates a new instance of the class. Method references are resolved as follows. Corresponding class attribute is searched, descending down on the chain of base classes if necessary. And the method reference is valid if this yields a function object. This yields a function object. Okay, so it keeps looking until it finds a function object, which is fine. Derived classes may override methods of their base classes because methods may have no special privileges when calling other methods of the same object. A method of a base class that calls another method defined in the same base class may end up calling a method of a derived class if that overrides it. Okay, there's a little. Okay, I have to read this again. Because methods have no special privileges when calling other methods of the same object, okay, a method of the base class that calls another method defined in the same base class may end up calling a method of the derived class that overrides it. Okay, this makes sense too. So you have you have a base class and then you have a derived class. You're calling a method of the derived class, but the derived class doesn't have that method. It goes to the base class, right? And if the base class is calling a method, that could be overridden in the derived class, and it's going to call the derived class. So it's all the time it's a derived class. Again, same as Java. If it doesn't find something, only then it goes to the base class. This applies not just to the direct call that someone else outside the class makes, this also applies to the call that the method in the class itself makes. There's no distinction, is what this is saying. Okay. For C++ programmers, all methods in Python are effectively virtual. I don't remember virtual in C++, but I'll trust that that's what it is. An overriding method in a derived class may, in fact, want to extend rather than simply replace the base class with the same name. There's a simple way to call the base class method directly and just call base class name dot method name of self comma arguments. Ah, I see. So it's like super, right? It is like super. Good evening. Good evening to you, Rishi. This is occasionally useful for clients as well. Note that this only works if the base class is accessible as base class name in the global scope. Oh, in the global scope. It has to be accessible in the global scope. If not, it doesn't know what base class name is. It's not going to find it. Okay. Python has two built-in functions that work with inheritance. There is an is instance to check, oops, is instance to check if an instance type is, check the instance type is instance of object, comma, int. What is int? Will be true only if object dot dunder class is int or some other class derived from int. What is int? Oh, it's just talking about int. Okay. Okay. That was an example. Okay. I thought int was some key thing that was related to inheritance. Okay. This subclass is used to check class inheritance. This subclass of bool, comma, int is true since bool is subclass of int. What? Bool is a subclass of int? However, is subclass of float, comma, int is false since float is not a subclass of int. Why is boolean a subclass of int? Is it treating it as 0 and 1? Is that why they're doing it? It just seems odd. It's an implementation detail. It's one of those JavaScript things. Is an empty array an object or whatever, right? It's crazy. The developer shouldn't need to know that bool is a subclass of int. It's weird that they've exposed it like that. Oh well. I'm guessing you wouldn't write code to see if bool is a subclass of int. Okay, multiple inheritance. Well, actually, let's test this out. There are a couple of other things that I want to verify. So I'm going to write a. Um, Actually, I feel like I should break this down into folders so that we can group what experiments we do on each session. Right now, it's all inside um, one folder here, which is not really nice. I'm going to create one folder here called older sessions, and I'm going to create one which is session 6, and I'll try and group them based on what we did in each sessions. Okay, so this is session 6, and I'm going to put all this stuff over here. All this stuff is going to go into older sessions. I wonder how many of those Python scripts are going to break now because they have some kind of a link. Make videos available on Udemy. I have a few available on Udemy, but it didn't get a lot of traction. Um, I don't know. I don't know. It's just I'll see what I can do. I'll see what I can do, Kara. I have a few videos on Udemy though, by the way. If you want to check a few courses on Udemy, if you want to search for it. Okay. Session 6. All right. Let's create one here. I'm going to create a class. No, this is inheritance.py. I'm going to create a class person. You gotta have class person, right? This is going to have a def init, right? This is a constructor, and in the constructor, I can assign, I can pass arguments. So let's say I have first name and last name. I'm going to pass them in, right? So this first one is going to be self, obviously. Second one is first name, and the third is last name. And now here I need to, I can't put member variables over here, right? That's not going to work. I need to do here self dot first name equals first name, right? Now I have a class which has first name and last name. Now I can say x equals new person. No, new. I keep doing this. We don't need new here for Python. I'll pass in my first name and last name. And then let's have a print here as well, a method. Okay, I'll have a def print name, and this is going to print f string. I'll have to do self dot first name, self dot last name. Wait, can I not do self here? I cannot because I'm not passing self. Or do I? Does self go in every method? A little confused by that. Let's see. So I have this, and I'm going to do x dot print name. I think self goes into every method. So even if you don't, even if you're like you have other variables, other arguments, you have to accept. Like all class methods need to have self, right? Right? I think so. Let's see. I'm gonna go to x dot xbill session 6 and Python inheritance.py. Okay, so self is one of those arguments. Now I have this here. Cool. Now I'm going to create a new class which inherits from person. Let's call it programmer. Okay, a programmer is a person, or at least that's what they think. Programmer, and I'm going to have person as the thing that it extends from, right? And what do I do here? Let me say I don't need to do init, or maybe I need to do init because let's actually do these two. I'm going to copy this and I'm going to strip this out afterwards. Okay, I'm going to have first name, last name, and then what do we do for programmer? Language, fave language. Okay, and this is going to be fave language. Self dot fave language. Okay, now I've got this person. Now I'm going to create one more. No, I'm going to actually call this, I'm going to create a new programmer. Okay, this is going to be programmer of, and I need to pass in a favorite language because it'll be Java. And now if I print name for programmer, it should print this. Okay, so it has that. Now let me try and remove this thing. So in it, I don't need to do this for these two. So I can say self dot what was the constructor, like if you had to call the parent. Wait, it was there somewhere here. Derived class name creates a new instance. Okay, so I have to do base class name dot and then method name. Is that what's needed here? Like, do I have to do person dot init of first name, last name? Is this what I have to do? This looks a little clunky, looks a little odd. But if I do this, do I get back what I had over here? I'm not so sure. Let's find out. Yeah, doesn't quite work. Personal request. Okay. Do I have to pass in self here? Okay, so that worked, but I don't know if that's what you're supposed to use. Is this what you're supposed to use? I don't know. We'll find out. Now, I want to mess with this a little bit. Okay, I want to mess with this by doing over here. I'm going to first change this to, I'm not going to put self dot first name, self dot last name in true object oriented programming style. I'm going to do person dot print name of self. Call dunder init on self. Ah, okay. So it's instead of person, I just do self. Yeah? Is that what you mean? Let's see if this works. Because they said over here, the documentation says you got to use base class name dot method name. Okay? Base class methods directly. Okay, but this might work as an instance, is what you're saying. Okay, let's try this. Here I'm going to do self dot print name. Then I don't need to do this. I think they both work the same way. Like if I call the base class dot method, I had to pass self, and if I'm just using, self, then I don't need to pass those things. Oh, I cannot pass self here. Okay, 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 okay. Yeah, that'll not work because this is going to the same constructor. This will not work. I have to call the base class name, right, and then pass in self. So similarly here, I have to call person dot print name of self. So I'm passing in self, and none. What? Self is confusing. Oh yeah. Oh yeah. Oh yeah. 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 Okay. So see, Python doesn't like us, right? Not only am I a Java YouTuber trying to learn Python, there is the output. The program that I write has an output that says none loves Java. What? How dare you, Python? Okay, let's figure out what's going on here. Why did it print none? Is it because it goes to uh, the top part? Okay, here I have init. So init seems to be working fine, right? This is where it's a problem. So, oh, I know. I cannot do this because it's not returning it, right? This is not returning it. That's the reason why. It's just printing. So obviously you get none. So I cannot do this. This is just me being silly, okay? Yeah, this makes sense. So here, I have to do what I did before. This is fine. Okay, self dot first name, self dot last name, loves self dot fav language. Okay, now this should work fine, and it does. Yes, cool, 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 cool. Hey Kaushik, wanted to say thank you for all the efforts and hard work. Important role in my professional career. Well, thank you so much. It means a lot to me that you say these things. These are the kind of comments that keep me going. Thank you so much for commenting. You've made my day. Thanks a lot. It's really nice to hear things like, I'm just here talking to my camera and posting videos. The fact that it's affecting people's lives and their careers is like mind blowing. I'm very grateful. Very, very grateful. Why do we need a call? Why do we need to call init on the base class? Well, I did this because I wanted to not have to do this again. Okay, so here I'll tell you. We have we have a programmer who has the same first name and last name. Okay, first name and last name properties. So here you see I have here there is first name and last name, and there is print name which prints those. That's the person, right? Here I have a programmer who extends from person. I want to assign first name, last name, and assign a favorite language. So I thought, well, why do that again if I can just delegate that to the parent? So it is, yes, you're right. It is kind of like super. Exactly. This is super. So sorry, I pressed something by mistake there. I didn't mean to. I didn't mean to make that noise. This is kind of like super. It's calling the parent class's constructor, right? And I'm passing these two, and then the only extra field in this class I'm assigning over here, and this one's you know, this one's obvious. I couldn't do that because it was like, if I had returned the value, then maybe I could have done this. Okay. Can't we do super dart init? I have no idea. I have no idea. Let's find out. I don't think you can do. There's no super. I can do. Uh, what would be the equivalent? There's no super here. Code Labs Pro. There's no super. The super keyword doesn't exist. So I have two options. I can either call the class itself. I can say person dot, or I can do self dot. Okay. I cannot do self dot for init because I already have defined the init. It's basically going to be recursively calling itself. So the only way to break it is by calling person dot. There's no super keyword. The other thing that I wanted to do was to check if uh, this was a an object. Okay. Okay. I just joined. Can you tell me why and how you're learning Python? I can also tell you where and when I'm learning Python. Okay, I'll answer all the four questions because this keeps coming up. Why am I learning Python? Because seems like a cool language. Everybody's talking about Python. There is a lot of momentum in the AI field, which is primarily using Python, and I feel AI is going to affect all of us developers. It's a good tool for us to use, no matter which stack you're working on, and needing to dive into AI requires at least a basic knowledge of Python. So I'm learning Python. That's the why. How am I learning Python? I'm learning Python using the official docs. This is the official docs, which is on docs.python.org, their official tutorial. I'm learning by reading this, and I'm doing practice exercises. So basically, when I learn a concept, I just go type that out in the code like I'm doing now for inheritance, right? I'm going to type that out in the code, mess with things, right? I'm going to do pass something which I'm not supposed to and learn. That's how I learn, okay? Do all kinds of weird stuff. I'm going to do a weird stuff now. So wait and watch. So I do all kinds of weird stuff, look at what the output is, learn from that behavior and move on and constantly do it. And in between sections, I do exercises. Okay, so here is the exercises folder where I actually ask ChatGPT to say, okay, give me an exercise on this concept, and it's going to give me a problem. Then I go solve that problem, and then I put this here. I write what the problem is that I'm solving, and then I solve it in the code, and then move on. So that's the how. Okay, where am I learning Python? I'm learning Python live on YouTube. Okay, I am not learning outside the stream. So basically, what I want to do is document every learning experience that I've had with Python on live stream. So I go live and I learn, and I urge you to learn with me. And it's like every discovery, every aha moment, every bad decision, every mistake, it's all recorded so that you can learn from it, hopefully, and not make those mistakes. And the last question is when. The when is a little bit of a tricky question to answer because I stream when I have time in my schedule. However, I'm trying to set up these live streams in advance. So I go to my channel, you should see live streams coming up. That should tell you when the next live stream is. Okay. And try and catch me there. If not, these live streams are recorded. There is a playlist in this description as well. You can go watch all the previous ones and kind of work with me and learn with me. There you might have there's an implied question here that usually comes up, which is like, hey, are you not doing Java anymore? Well, I'm going to tell you the answer to that, which is sitting over here. See this? Okay, that hasn't changed. I'm just learning a new language. Doesn't mean that I'm not doing Java, right? I'm not married to Java. These are all my friends. Java is my friend. I'm going to have a new friend, and we'll all hang out together. Why not, right? Okay, This is a great approach. Thank you. How many lives do you do in a month? I do not know. I do not know. I try and do as much as possible. I have a full time job, guys. I have a 9 to 5 job. So it's whenever the job allows me to go live, I go live. That's my main job, is my priority, but this is my passion. So whenever I have time, I do this. Again, I'll try and schedule these live streams ahead of time so you will know when the next one is coming. We're all learning together. I'm glad. I'm so glad. This is the intention behind this. Click the notification bell. Yes, yes, click the notification bell. I'm a bad YouTuber. I don't do these things. Click the subscribe button, click the notification bell to be notified so you will know when I'm going live. And you also have, I think it notifies when I schedule streams as well. It's a cool way to learn. Yes, it's actually a good time to learn because even if you're doing Java, even if you're doing like the bulk of the code that you're writing for your application is written in Java, you can offload some of the things to AI. So it kind of brings about a new dimension to the kind of apps you're going to build. Imagine you're building a Spring Boot application where you can have people enter text to natural language and you provide the responses. Well, you can do that. You can build the application in Spring Boot and then kind of offload the natural language part to an AI thing that you stand up. You learn enough Python so you can stand that up. Your application gets a whole new dimension to your functionality, which is amazing, right? So all that is unlocked by just learning a little bit of Python, not a whole lot. You don't have to be an expert. You don't have to do AI research. Just a little bit of Python. Use AI as a consumer. You don't have to learn AI, right? No statistics and all that. If you want, you can, but just a little bit more effort. We bring in a whole lot of new capabilities to our application. That's what's very exciting, and that's why I'm doing this. All right, we will move on. So what I wanted to do was to check here if this is a class object that I'm passing in. Okay, so this is inheritance, right? This is inheritance, and you have, yes, yes. If you know Python and some kind of an API framework, like basic API framework, like you said, Fast API or Django, you can just use that API for the AI part of it. Okay, that becomes a separate microservice, and you can have rest of your Java microservices, and that just becomes one service that you call for like the fuzzy things, right? Everything in Java is more precise and more deterministic. You can get the fuzzy thing from this other microservice and kind of stitch them all together, and your application is going to go from here to here because of that additional feature, which is amazing. Okay, so what was I talking about? So this is inheritance, and I'm inheriting from class person. Now I can pass in a class to this, which I'm assuming is a class object. Now my question is this a class object or does it have any other significance? So here's a way I can find out. Now I can print person here, and we know that person is a class object. It's not an instance of the class, it is an object which holds the class definition. Okay, so if I were to run this, you see this? It's an object that holds the class definition. This is what it's class person. Okay, now my question is, can I just hold on to this? My class equals person. Okay, and can I pass here? You know what I'm doing, right? My underscore class. Can I do this? I don't know. The documentation wouldn't say stuff like this, but it's me who does all this kind of crazy stuff. Let's see if it works. It works. So basically what you're doing is you're passing in a class object into an inheritance class definition. So it's almost like this is almost like a function in a way. It's like a definition is basically executed and you get an object out of it. It kind of returns an object. So it's almost like you're passing in a method, kind of. It's in a weird way because you're not. It's not passed in as an argument. You're literally taking in what is in the scope and passing in over here. So it's interesting that it does that. I'm gonna get rid of this and put back person. Okay, so now we have inheritance. Let's try and do the multi-level thing. Okay, so I have print name, and here I'm gonna call print name It's not good practice. Yeah, of course, of course, you shouldn't do that. I was just trying to see what it is that's getting passed. It seems like the function. It seems like the class object itself is getting passed. That's strictly to aid understanding, not for writing code. Thank you for calling that out. I'm going to call this print name and language. Okay. Now what's happening is I have. Um, is this font size okay? The other one seems like a little too big. Is this good? Let me know in the chat if this is okay. I don't want to make it too small that it's hard to read. Some people watch these streams from the phone and it becomes very hard once it goes below a certain font size. Okay, so I'm going to have print name and language over here. First, of course, this one and this one. So basically, it should do what inheritance does. Okay, print name and language gets it from the child class. The derived class is what it's called. And if you just do print name, it is going to go to, it's going to try and find it here in the programmer class, which is what X is, and it doesn't find it there. So it's going to go to the parent class. All right. This is simple inheritance. We are Java developers. We know this stuff, at least the concepts. Slightly off topic question. Do you have any experience with open source development in Java? Any tips or insights you can share about this? I was going to make a video about this. A lot of people have asked me this open source contribution. My first question when they ask me this is, why do you want to do open source contribution? And a bunch of answers. Depending on why you want to do it, I have different tips. So let's hold off on that. I'll make another video about this. All right. Put a marker here. I'll make another video. Okay. That was inheritance. Where are we? We are here. Okay, we have two built-in functions to work with inheritance. Is instance is to check if a certain object is the instance of that thing. Is subclass to check inheritance. Let's verify those two as well. Okay. This one, I'm going to put this at the top. Calls method of the derived class. This one resolves to the parent class. Okay, now I'm going to print is subclass. And then what I want to print is subclass of, and then I pass in, what were the two parameters? Uh, first is the object and second is the type. Okay, so first is the object, which is X. Second is the type. Well, it's not really type. It is a class object. Okay, first is the instance object. Second is the class object. And then this one is class type, and this one is instance. X programmer. Both should return true. Arg1 must be a class. Oh, okay. Arg1 must be a class. Person and then X. Is that true for this one as well? I'm guessing so. Is subclass R2 must be a class. What? They both have to be classes? So you're basically just examining classes then. Huh. So let's verify. Programmer and then person. Ah, so this one's just verifying the class, not the instance. I see, I see. Bool is a subclass of an. This is like, they should have come up with a better example for this. This one's Bool is a subclass of int. Why not pick something which indicates that this is a subclass or a parent class? They don't get it. I don't get it. It's multiple inheritance. No, this multiple inheritance is coming up next. This one's this one's just this, right? Like we're trying to get the is instance and is subclass to verify. Yeah. Python supports a form of multiple inheritance as well. Um, a class definition with multiple base classes looks like this: derived class name, base 1, base 2, base 3. Okay, so you have multiple. It's inheriting from multiple base classes. Hmm. Supports a form of multiple inheritance. Okay. For most purposes, in the simplest case, you can think of the search for attributes inherited from a parent class as depth first, left to right, not searching twice in the same class, where there is an overlap in hierarchy. Thus, if an attribute is not found in derived class name, it is searched for in base 1. Then recursively in the base of base 1 was not found there and searched for in base 2. So it's kind of like one after another, right? It's like it's going to go look for base 1 and its parents, doesn't find it, it's going to look for base 2 and its parents, then base 3 and its parents. Hmm. Okay. Okay. Well, I think we'll see once we get into this a little bit more. Does Python seem more or less logically structured than Java, or does it seem more cool? Um, Python seems to have, I feel like logically structured is subjective. What I've noticed Python do is it has assigned a lot of the burden, a lot of the responsibility to the language itself. Whereas Java assigns a lot of the burden to the classes and objects that kind of get bundled in with the Java core, with the Java SDK. Okay. So for example, data structures. Java has a huge data structure library, but Python kind of bakes that into the language, right? It has the basic data structures, which are pretty powerful, and they have all the methods that you would expect in a collection framework. But they're kind of baked into the language. And I've seen this for a lot of other things as well. So I don't know if one is more logically structured than the other. Just a different approach. Regarding what's cool, I would say anything that's less rule based and more flexible seems cool initially. Like even JavaScript, right? It seems cool initially because you can do anything. We have this thing in our mind, this impression in our minds that somebody who's asking us to follow the rules and be good is not cool. Somebody who encourages us to, like, yeah, whatever, man, break the rules, we find them cool, right? That's the contrast between the teachers in school that we find not cool and a friend who's like, to hell with the teachers, who we find cool, right? So Java is like the teacher who says, follow these rules. We have the impression of that not being cool. But Python is like, yeah, assign whatever to whatever. Seems cool, right? You know what I mean? But I think what is the difference longer term is what's actually good for you, right? I'm glad that I listened to my teachers way more than I listened to my friend who was sitting next to me in the back bench. So it depends. Long answer, but I guess it helped in a way. I don't know. Let me know if you have any other questions. Python is more dynamic and flexible, so it gives us more rope to hang ourselves with, which is great when you're looking for a rope to hang yourself. Not so much when you're looking for something else. Yeah, that's true. That's true. Python gives us more rope, but it looks cool in the process. Uh, For most purposes, in the simplest case, you can think of the search for attributes inherited from a parent class as depth first, not searching for. Okay, we saw this thing, so it's kind of going to look at one after another. In fact, it's slightly more complex than that. The method resolution order changes dynamically to support cooperative calls to super. This approach is known in some other multiple inheritance languages as call next method and is more powerful than the super call found in single inheritance languages. Support cooperative calls to super. Okay, we have to understand what that is. I haven't covered it so far. Dynamic ordering is necessary because all cases of multiple inheritance exhibit one or more diamond relationships where at least one of the parent classes can be accessed through multiple paths from the bottommost class. Ah, yeah, that makes sense. For example, all classes inherit from object, so any case of multiple inheritance provides more than one path to reach object. Here, they don't have the problem because you have to do this with multiple inheritance. In order to solve the diamond problem, you need to have a sense of order. You're going to go, okay, left first, then the diamond problem is solved. Even if you have a diamond, if you're referring to something, it's going to go this way rather than this way, right? So, you know, this is left for you here. So I have diamond inheritance. Okay, you have a super class over here. You're calling from the base, and you have two paths to get to super, the parent of the parent. Now we can either go the left side or the right side. What Python does is it's going to go in order, left comma right, the right after that, and so on. So it is going to always go left first, even though there's another path. So there's no confusion. You always know exactly what path it's going to take to get to the common thing that these multiple classes it's inheriting from is shared. For example, all classes inherit from object. So this is the first time they've introduced objects. So it's similar to objects, the object class in Java, I guess. Object return a featureless object. Object is a base for all classes. Yeah, those methods are common to all instances of Python classes. The function does not accept any arguments. So it's a function. Ah, okay, it's a function. To keep the base classes from being accessed more than once, the dynamic algorithm linearizes the search order in a way that preserves the left to right ordering specified in each class, that calls each parent only once, that is monotonic, meaning that a class can be subclassed without affecting the precedence order of its parents. Hmm. Speaking of offering a rope, this seems like a really nice thick rope that it's offering. I cannot imagine this doing what you want it to do. But then I'm a Java developer. I don't know about multiple inheritance. I have a bit of resistance. Like my initial reaction is resistance to multiple inheritance. Maybe I'll change my mind once I learn how they do this in Python. Okay, this didn't make a lot of sense to me. Did it make sense for you? Let me read this again. To keep the base classes from being accessed more than once, the dynamic algorithm linearizes the search order in a way that preserves the left to right ordering in each specified class, calling each parent only once, and that is monotonic. So until this part, I understood, right? It calls left to right, it calls it only once. Once it finds it, it resolves it, it's done, right? And that is monotonic, meaning that a class can be subclassed without affecting the precedence order of its parents. A class can be subclassed without affecting the precedence order of its parents. Not sure what that means. Why would a subclass affect the precedence order of the parent? If the parent has a comma b comma c in the constructor, like in the class definition, that should be the order. Why would a subclass affect that? Taken together, these properties make it possible to design reliable and extensible classes with multiple inheritance. For more detail, see this. Okay, so this is probably going to be a okay. I'm gonna have to read this and try and understand what's going on here. This is like a whole document. I'm not gonna go there now, but make a note of it and try and get to that later, perhaps in a different live stream. And again, remember the rule: Any learning I have to do it live. So I'm going to be doing this live as well. Okay. I don't know when, but we'll see. Private variables. Private instance variables that cannot be accessed except from inside an object doesn't exist in Python. Okay. However, there is a convention that is followed by most Python code. A name prefixed by an underscore should be treated as a non-public part of an API, whether it's a function, a method, or a data member. It should be considered an implementation detail and subject to change without notice. So Python doesn't have private variables. All variables are accessible outside. So if you want private, put an underscore in the front and hope for the best. Since there is a valid use case for class private variable members, namely to avoid name clashes of names with names defined in subclasses, there is limited support for such a mechanism called name mangling. Since there is a valid use case for class private members, namely to avoid name clashes of names with names defined in subclasses, there's a limited support for a mechanism. So it's not about private, but it's about using class private. You don't want a a member to be overridden by a child. That's name mangling. The identifier of the form underscore underscore spam. At least two leading underscores. You can have more underscores if you want. At most one trailing underscore is textually replaced with class name underscore underscore spam, where class name is a current class name with leading underscores stripped. This mangling is done without regard to the syntactic position of the identifier as long as it occurs within the definition of the class. So the Python does this. If I just name it like this, Python changes it to this, and now I have to use this. Why Python? Why? Why not just have private variables? I don't get it. Let's do this. Let's test this out. I want to see what that looks like. Okay, I'm going to create a new file here. Private variables. Okay, I'm going to create a variable, a member variable called underscore underscore, and then the variable name. I'm going to copy this definition here. And I'm going to have, can I do, no, it's not going to be self-star. It has to be class variables. So I'm going to have underscore underscore foo equals 10. Now, can I say person dot I do have underscore underscore foo. It hasn't changed it. So basically what it's saying is at most, oh, it has to be a class variable. Oh, it has to be an instance variable. You see this? They're doing an instance variable. Let's look at the example and then we can write the code. This underscore syntax make Python not as readable as Java. Yeah, it's also convention based. It's like, we could have private variables. I'm gonna miss private variables when I start coding in Python. I'm kind of used to that. It's this underscore nonsense looks really bad. Name mangling is helpful for letting class subclasses override methods without breaking intra-class method calls. So we have mapping as a class. It has self and iterable. Self.items list is empty list. Self.update of iterable. What does update do? In every item in the iterable, it adds it to item underscore list. Okay. And you have underscore underscore update equals update. Yeah, I'm not sure about this as well. I'm trying to find out what's happening here. It's a little weird. I agree. Mapping subclass provides an update with key and values. Okay, for item in zip of key comma values, select items list start append of item. So So it's sending this here, and it's calling. So first, let's look at one at a time, right? You create a mapping subclass, instance of a mapping subclass, right? What happens? It gets the stuff in mapping as well. So it gets this thing, and it gets the um, underscore underscore. It calls underscore underscore update, right? Before init is called, it does this. So it basically takes a function that is they're called dunder methods. Yes, you're right. The underscore underscore is called dunder. They're used in JavaScript as well. You have dunder proto methods. Um, I'm going to call it dunder. Okay. This is assigned to dunder update. I think dunder requires the underscore at the end as well. I don't know. Okay, we're just going to call it dunder either way. This is assigned to dunder update. So this happens when the class is being initialized, right? When the class object is being initialized, not when the constructor is being called. When the class object is being initialized, you have what they call a private copy of the original update method. They've created a private copy by assigning this to this underscore underscore. Okay, now a class is being created. They passed an iterable to it, and then they call the underscore underscore update copy. They're not calling self dot update. They're calling self dot underscore underscore update. Now, what this means is even if somebody were to override the update method later, okay, so let's say I have a mapping subclass, we are overriding the update here, it is still going to call, when the constructor is called, it is still going to call the original copy, right? Still going to call the original copy. And they have to do this because otherwise you end up with recursion. So the child class is doing this. Okay, it's doing keys and values. The parent class has the same update, which is doing iterable. So the child class takes keys and values, zips them up, so you get an iterable, and then calls. Um, no, it's not even doing that. It's basically just appending it right here. I don't get it. What's the point? The above example would work even if mapping subclass were to introduce an underscore underscore update identifier, since it is replaced with mapping underscore update. Ah, okay. Hmm. There's a constructor. This is a constructor. Dunder init is a constructor. Okay. So when mapping subclass is called, the constructor is going to be the parent constructor because the derived class doesn't have a constructor. I don't know, man. This is weird. All right, let's try this out. I think it makes sense only when we write the code. So first, what I'm going to do is put it into self because that's what we made a mistake. This is not. It's not this. It is no. It is actually that, right? Wait, I'm confused. It is that. It's not self dot. It is. Hmm. No, I'm confused. Okay, let's try this. Underscore underscore foo equals 10. Okay, and then here I do self dot underscore underscore foo equals 20. Now I create x equals new person. Good that I copy pasted. Otherwise, I'm sure I'd have written new there. New person. I gotta get away from that habit when I'm writing Python. So now here I can do x dot. Let's actually print out all the things. This is useful for that. All right, I'm going to print. What are the contents of dict when this happens? Python private variables.py. Okay, see, there we go. That's what's happening. So it's internally converting. We can call this, but internally this is what's happening. You see, underscore Python underscore underscore foo. It's done that conversion. So it kind of like binds it to the parent class. So even if you have the same name, just the fact that you're putting two underscores in the front means that each derived class gets its copy. Okay, that's the benefit of it. Now, if I have programmer, this thing here, okay, and I'm going to put the same thing here, right? I'm going to override this. I don't even need to do this. I think I don't even need to do this. So I'm going to create a programmer with underscore underscore foo is 20 perhaps. Now, if I were to create a new programmer, I'm going to get the programmer underscore underscore and this thing. Okay. Foo becomes a static member. I don't know if it becomes, it's not really a static member. It's basically just assign it kind of think of it as you're creating a unique variable for each class. Okay. By default, it is static. Unless you assign it yourself, it becomes static. But I think this is true even for instance variables as well. Let's try this out. So we have, wait, what happened now? I had to do self. Okay, that was the problem. That was the problem. Self dot foo equals. I'm gonna make this 20, and then this one, I'm gonna make this 30. Okay, and can I get rid of these ones? Okay, there we go. This makes sense now. So what's happening is we have the same variable in both the parent and the derived class, right? The same variable. But and if I had not done this dunder convention, if I had not done that dunder convention, the derived class would have overridden what was in parent, right? It would have overridden what was in parent. And we don't have private variables, so you cannot protect from overriding. So what is Python solution? Python solution is like, okay, when you have this variable and you don't want a derived class to override it, well, either you have to create a unique name or use this convention so that Python can create that unique name for you and you don't have to worry about it. Okay, so I just stick this dunder. And now when I run this, you see here it's changed to person underscore underscore foo. Okay, so it's converted it to unique name. So even if the derived class were to use that same name, well, guess what? That's going to get its own prefix at the front. So it's not going to override it. Okay, so you by doing this, I've essentially said no matter what the child class does, it's not overriding it, right? But it could. What if I create a variable like this? Wouldn't that technically override it? Equals, I'll say 40. What happens now? I've overridden it. What's the point? Well, I guess again it's convention. You don't do this stuff. Again, it's like don't do it. It is possible, but don't do it is I think what the meaning is. I don't like this. This is bad, bad, bad. But do we all understand? This is what's happening here. It's basically, you know, try and avoid using the same name. If you use some name and you want to be most likely you don't want somebody else overriding it, even though they technically could. You don't want to override it. Well, just put the dunder syntax in the front. Okay. Dunder syntax is used doing a lot of heavy lifting. Yeah, yeah, kind of. It's all convention. So, oh well, lets you do anything. It's a cool language, guys. Python. It's kind of like JavaScript in that sense. It's very flexible. We have TypeScript to fix the problems of JavaScript. I wonder if there is type Python to fix the Python problems. But it makes sense. Overall, it makes sense. Okay, let's move on. Okay, we covered this. Note that The mangling rules are designed mostly to avoid accidents. It's still possible to access or modify a variable that's considered private. Yeah, we already did that. This can even be useful in special circumstances, such as in the debugger. Okay. Notice that code passed to exec or eval does not consider the class name of the invoking class to be the current class. This is similar to the effect of the global statement, the effect of which is likewise restricted to the code that is byte compiled together. Note that the code is passed to exec or eval. Does not consider the class name of the invoking class to be the current class. Does not, okay? Excuse me. Exec or eval. Similar to the effect of the global statement, the effect of which is likewise restricted to code that is byte compiled together. I didn't understand this. Didn't understand this. The same restriction applies to get attr, set attr, and del attr, as well as referencing dict directly. I did not understand this thing at all. I'm going to copy this, and this is something that I'm going to have to clarify as well. Odds and ends. Sometimes it's useful to have data type similar to the Pascal record or the C struct. Bundling together a few named items, data items, the idiomatic approach is to use data classes for this purpose. Okay, so it's kind of like a record. It's like Java record, right? It's a data class. Class employee, define these. I'm guessing these are just documentation strings, and they're not indicative of types. Then you do this. A piece of Python code that expects a particular abstract data type can often be passed a class that emulates the methods of that data type instead. For instance, if you have a function that formats some data from the file object, you can define a class with methods read and readline that get the data from the string buffer instead. Okay, so let's see. So we have a data class. So you have something called a data class, and there's an annotation which they haven't covered yet. Oops. They have something called an annotation. And let's actually try this out. I'm going to go here to a new file, data class. I'm going to have the same person. No, I don't need to do self anymore, right? For this one, I'm going to have class person, and this one's going to be a data class. From data class import. What was that? Data underscore class? No, data classes. Okay. I was importing myself. Data classes import data class. And now I can stick this annotation here on top saying this is a data class. And now here I can say first name is string, last name is string, and then age is a number, no, int. Now can I say x equals new? I keep using new. X equals person. Ah, look at that. So I can automatically pass in those arguments and I don't have to do all that, the whole like putting itself and all that stuff, right? And this makes it easier. So again, I'm going to pass my name. and I'm going to try and let's first print it. So we should be able to see the two-string representation of this data class. Okay, so it has a two-string representation of the class name, and it has the values over here. Now, what if I change it? Is it immutable like Java records, or can this be changed? Okay, so it can be changed. So it's basically just a shortcut for creating objects. You can change it. Can I put a method here? Do I need self? Lots of questions. X darn print. Okay, I don't need self. Oh man, this is useful. This is useful. I hated self. So you don't have to pass in self. Oh no, actually, hang on. This is what I needed to test. Yeah, you'd have to pass in self. Okay. 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 I guess it's needed because there's no implicit argument, right? We in Java we have an implicit this, but here there's no implicit this or self. It has to be passed in every time. So I have to do something like this so that I can access the the variable. Say self dot first name. This kind of necessary. Okay, so this is data classes. Interesting. A piece of Python code that expects a particular abstract data type can often be passed a class that emulates the methods of the data type instead. For instance, if you have a function that formats some data from the file object, you can define a class with methods read and read line that get the data from a string buffer instead and pass it as an argument. Yeah, so this is duck typing, right? It's you don't have to have the exact type as long as you have like a thing that can perform that operation, you should be good. Again, just like JavaScript. Instance method objects have the attributes to. Dunder self is the instance object with the method m, and m.dunder func is the function object corresponding to the method. Where's m here? No, they're talking about a new example. So self is the instance object with the method m. So every method has a property has an attribute called dunder self, which points to the instance object, and func is the function object of corresponding to the method. I see. Okay, okay. So we learned in the previous stream how a method is basically a combination of the instance object and the function object, right? So we are basically we'll be able to parse those two. You get self and you get func, right? So to illustrate the example here, I've got I've got this here, and I'm gonna say extracting instance and function objects. Okay, so method object equals x dot print, right? This gives us the method object. And now I'm going to say function object equals method object dot underscore underscore, I should say dunder func. Wait, there isn't? Instance method objects have attributes too. This is an instance. It's an instance method. This should have attributes. Dot. So why isn't there a func here? There isn't a self either. Let's see if it shows up in the the just these classes. Maybe it's a data class that's causing a problem. x dot print name dot. Nope, it's not showing up here either. Instance method objects. So I'm not sure I understand what this is. So M is an instance object with the method m.self, and yeah, I don't understand this. So I'm going to put this in the to do. Okay. So that last part I didn't understand because this is supposed to be the method object, right? When I get this, this is supposed to be the method object. So here I can print method object and it should show me that this is a method, right? See, it's a bound method, person.print of person, right? And what are the properties of that method object? What does it have? It has nothing. Interesting. Okay, so I'm not sure I understand what's going on here, but that's what this thing said. Do you get rid of this? We'll have to figure out what exactly this means. I didn't quite understand it. Okay, before moving on to iterators, we're going to take a quick break. It's been 1 hour and 15 minutes since we started the stream. We're going to take a break for 10 minutes and we will reconvene. Okay, so I'm going to set the timer for 10 minutes and I will see you folks in 10 minutes. Hello and welcome back. We are going to continue our journey of Python. Let's see if I can get myself back in the frame. All right, there we go. Thank you for all the videos. The best in-depth explanation. Bit new to your channel, but I expect to stay long. Thank you so much for joining, and I hope you continue to get value. I'm going to say hello to Rishabh for just being a member. Welcome, my friend. I hope you like the content that you have in store for you as a member. There's a whole lot of stuff. So I hope you enjoy it. Happy binge watching. All right. So we are back and we are going to continue where we left off, which was iterators. By now, you have probably noticed that most container objects can be looped over using the for statement. Yeah, we saw that. Like we had lists, we had the iterables, which could be iterated over. Tuples can be iterated over. In this case, the objects can be like dictionaries can be iterated over. Strings can be iterated over. We can open a file and iterate over it using lines. Okay. Um, how do you become a member? There should be a join button on each of the Java Brains videos. Anytime you see a Java Brains video, there should be a join button next to subscribe. So it's a monthly membership, but once you join, you get access to a bunch of exclusive courses. You go to the channel page, you can see all the exclusive courses that you can access. Check it out and let me know if you're not able to see it. Um, okay, so we have all these iterators. This style of access is clear, concise, and convenient. The use of iterators pervades and unifies Python. Behind the scenes, the for statement calls iter on the container object. Okay, the function returns an iterator object that defines the methods dunder and next, which accesses elements in the container one at a time. When there are no more elements, dunder next returns a stop iteration exception, which tells the for loop to terminate. This is a classical iterator pattern, right? You call a method to get an iterator, and the iterator has a next method, right? You call the next method and you get the next method, the next object in the element. And if there are no more elements, you get the stop iterator exception. Again, remember this, you've noticed this. Python is a little more liberal with throwing exceptions. It's a part of the API. Exception is not as much of an exception in the true sense of the term that we use in Java. Java, when you have an exception, that means something exceptional happened. There is some kind of significance to it. But with Python, it's like it almost treats it like a normal flow of things. Okay, you want to get out of something, just throw an exception, catch it, and then do it something. It seems like it, but I don't know. I could be wrong. In this particular case, it is. It seems to be similar. Is there buzz in the audio? Oh, thanks for letting me know. I don't know why. I honestly don't know why. Let's see if I can plug it out and plug it back in. Okay, give me a second. Okay, I just unplugged and plugged it back in. I'm going to switch back to the main microphone. Is this better now? Do you still have the buzz? I'm gonna have to wait for a bit because right now I'm not seeing the answer. You're probably seeing this after you type your message and you're like, what's Kaushik doing? And I'm waiting for your response to come. Let me know if you can hear me okay or if there is still a buzz. It seems fine now. Okay, cool, cool, cool. Thank you. Thank you. All right, so this is the iterator pattern. It throws a stop iterator iteration exception, which is I think common to a bunch of other languages as well. When you're trying to get an object from the iterator pattern and it doesn't exist, it throws an exception. It has to because anything that it returns can be misconstrued as the thing that existed that you're trying to get, right? Which makes sense. Um, the exception which tells the for loop to terminate. You can call the next method using the next built-in function. This example shows you how it all works. Wait, why are they talking about this now? Why are they talking about iterators in a in a page about object classes and inheritance? It's kind of weird. Okay, well that's fine. We can still figure this out. So we have um, the string here. You get an iterator by calling iter on the string. We have the iterator. You can do next of iterator. Okay, and next is basically going to call the dunder next of the iterator. This is equivalent to doing it dot dunder next. And you just do this until you get a stop iterator. Is there a has next? There should be a has next. Self dot index. I have no idea what this is doing, but let's go one at a time. Okay, we're gonna go to iterator now. New file, iteration.py. Okay, so I have a string s equals foobar. Let me actually create a list now. We already saw a string in the example, so we're going to do a list, and I'm going to have a iter of s is going to give me iterator object. Okay, I'm going to do iterator object next of iterator object will give me the first element, right? If I were to print this, I'm going to get the first element, right? And I can do this a few more times and I'm going to get all those elements. Not this one. Python iteration.py. Okay, so I get those elements one by one. Um, and this is equivalent to calling iteration object dot next, right? Dot dunder next should be the same. Okay, so it is the same. Now let's see what else this is saying. Having seen the mechanisms behind the iterator protocol, it's easier to add iterator behavior to your own classes. And that's the reason why they're mentioning this here. Now I understand it. What's the difference between an array and dict in Python? Well, they're very different, my friend. There's no array, there is a list. Okay, so this is a list. What we see here is a list. Okay, a dictionary is something like this: name. Okay, this is like a map, and it's like inline object definition in JavaScript. It's like a map of key to value, and you can iterate over dictionaries as well. In which case, you're going to get like the key value. Or is it just the key? I forget. Oh, you just get the key. You can iterate over a dictionary, and you're going to get the key. Okay. If you need both, you're going to have to do a zip. Zip is going to convert a dictionary into a list, which has the key value pairs. Okay, so now we understand why they're talking about this. Now we've understood what the iterator pattern looks like in Python. You can implement the iterator pattern to your classes. You can create your own custom class, and it is it's going to create a custom class. I got yeah, no worries. Let me actually post this here so that you have a link. Um, if this doesn't work for you, then it could mean one of two things. Either you do not have um, YouTube membership available on your in your location. It's a country based thing. So if that's the case, then you cannot become a member, unfortunately. Let me quickly grab this for you and then we'll move on. Membership. Okay, this one. Let's see if this works. It's your link. What about elements in parentheses? Those are tuples. If they're in parentheses, they're tuples. This one is like tuple equals 1 comma 2 comma 3. No, not this one. That's a tuple. Georgia, the country, yeah, you may not have access. You can go to my website and see there. I have the same content available on my website as well. So go to javabrains.io. That's more of under my control. It's not like YouTube. I have all of the same contents. In fact, that gets a little bit more love. The new content goes there first and then comes to YouTube. So try and see if you can get a subscription there. That might work too. Okay, so we've looked at the iterator for the the iterable stuff, and now we're going to move on to classes, right? This is how you do this. You define an iter method. Interesting. Define an iter method because that's what's going to get the iterator, and then you define a next method. So what they've done here is they've basically put all of them on the same object, right? You have this is the object on which you're going to iterate. It is going to return an iter. The iterator is itself, okay, because itself has the next method, and it's keeping track of the data. And if the index is 0, then it's the raises stop iteration, and if it's not, then it's going to subtract and then keep iterating forward, right? So this is using custom iterators, right? Let's do this now. We're going to create our own iterator object. I'm going to say class my student names, and I'm going to have init def init, which is going to take the self and a list of names. Okay, and it is going to do self dot names equals list, right? This initializes the names, and now I'm going to define an iterator, which again needs self, and this is going to return self. I'm going to define dunder next. Just going to take self, and then this one needs an index, right? This needs a self dot index equals the length of the list. I instinctively go list dot, right? With this one, it's a little different. You gotta choose len. Now what I need to do is get first check the length of the list if it's index if it's less than 0, or if it's equal to 0. No, less equal to 0, then you still have one value. If it's less than 0, then you throw an exception, right? So if say if self dot index is less than 0, then we have a array out of bounds, list out of bounds. So I say raise, what's that, stop iteration. Okay, else I'm going to self dot index minus minus. No, I cannot do minus minus because that doesn't exist. Self dot index minus 1, and then I return self dot the names of self dot index, right? So let's figure this out. It starts with the front, and that's the length, and now it's going to do 1 minus, and then it's going to return. And once it becomes when it's 0, it does 1 minus, and then okay, this has to be equal to them because it starts with the length of the list. Okay, so we've got this. Now I have s here. I'm going to create object equals my student names of s. Okay, I'm initializing with the list. Don't do it, Python cringe. Yeah, I probably will do Rust as well, but it's good. It's good to cringe sometimes. It's fine. I've done a bit of cringing already in this live stream. Don't worry. It has its good parts and bad parts. I'll admit it's not entirely cringy. It's been a mixed bag. Okay, so I've got this. I have the iterator pattern implemented in this class. I'm passing a list here, and now I'm going to iterate over this list. Okay, I'm going to get the iterator object from here, and I'm going to iterate over this list. So nothing has changed as far as this code is concerned. It is just that instead of pointing to the list directly, I'm creating a wrapper around it, and I'm iterating over an instance of that wrapper. So let's see if this works. I don't know if this works. Well, it actually worked. Let's make sure that it goes all the way and prints the error as well. Okay, it throws the error as well, which is good. It goes all the way to 1, and then it raises the stop iteration. Okay. We've done in reverse order. And then, of course, you have the loop. I should have done that itself. Now that we know that this works, we can do a for val in object. Print val. What's this called? What's the syntax for? I don't need a parentheses here. Why is it complaining? Doesn't want parentheses. Okay. Really? If I put a parentheses here, it complains? Huh. See, this is the cringe part. It's like I don't get it. Why? But okay. Very well. Okay, this worked fine. So this is cool. Okay, I'm seeing a lot of love for Kotlin here. Try to learn Python, but classes in Python, like Python is good scripting language. Try to keep track of class members in Python. Why should I pass self? I know self is a bit of a bummer. Like I don't get it. I don't get why you have to pass it. Kotlin is elegant. Kotlin also support WASM. You must use Java and go to Kotlin. Is trying to Android development. Kotlin is okay. Okay, cool. Yeah, we should probably try a Kotlin live stream as well. I'll admit I don't know Kotlin. I haven't coded in Kotlin before. So it can be one of those things that I do, like I'm doing here, right? Live stream where I'm basically learning Kotlin live, and you can join with me and learn with me. Okay, so we can try that. Well, Code Labs Pro, I'm guessing you're going to be way ahead of me in terms of Kotlin. So you might be able to school me when I make silly mistakes if you choose to attend that live stream. Okay, so we did iteration. Now we know how to do custom iterators. Let's move on. Generators. Generators are a simple and a powerful tool for creating iterators. They're written like regular functions but use an yield statement whenever they want to return data. So this is used in JavaScript. Generators are used in JavaScript typically for um, asynchronous work, right? So it kind of abstracts out asynchronous versus synchronous, and you just use a common paradigm for both. I wonder if this does async as well. I don't know. Do you enjoy indentation over brackets? Also, do you think it's better to use semicolon or not? I'm not too picky about it. What I don't like with Python is the kind of opinionated thing. Like you're not supposed to put parentheses in, stuff like that. It's like, let me do it if I want to, right? For this particular thing, right? What's the problem with putting it there? Why is it stopping me? It doesn't need to. Like if I'm in an if condition, I put a parentheses. Like why not do this? Um, yeah, so those kind of things. As long as it's flexible and I can do either, it's fine. So for example, in Java, you can do either and it's okay, but with Python, not so much. Indentation is like I gotten used to it. I'm not too worried about indentation. Even semicolon, I'm used to it because I have worked on JavaScript projects which haven't had the need for a semicolon. So it's like I've learned to switch in and out of it. It doesn't hurt me that much. Okay. Kotlin, still a lot of love for Kotlin. My goodness, I looks like I'm missing out. I'm gonna have to try that out as a language. Okay, okay. Generators. They use the yield statement whenever they want to return data. Each time next is called on it, the generator resumes where it left off. Excuse me. Its generator resumes where it left off. It remembers all the data values and which statement was last executed. An example shows the generators can be trivially easy to create. What are we doing here? Index in range. Then this is doing a yield. What is it doing? Is it like a hmm? So what we have here is a method that returns an iterator, right? Like a method that returns an iterator, and you can loop over. I'm guessing this runs reverse of golf, right? It runs reverse of golf, and it is what is it returning? This is probably kind of like syntactical sugar, where Python is constructing this iterator and returning it, or the generator and returning it. But you can loop over the result of that thing. Okay, okay. Let's try this out because I'm still not fully clear about this. I'm going to create one more. I call this iterator.py. Sorry. generator.py. Now I'm going to go get the same example here, but I'm going to do this iteration via generator this time. Okay, I'm not going to do next here. I'm not going to do these two. I'm going to do def reverse. So it is a method, which of course has to take self. And I'm going to return a generator. So the way the generator works is for, oh, it takes in the data. Okay, wait. It doesn't even need a method. Okay, it doesn't even need a class. So get rid of the class, put this method here. And then it takes in the data, which is basically that list. And it loops through the elements of that list in reverse order, right? It's going from the length to -1 with -1 increments, and then which is essentially a decrement, and then it yields data. Okay, and now I can pass this for val in reverse of s, right? This is what's happening. So again, I'm guessing reverse is called just once, or is it called every time? I feel like it's called every time. Let's verify that out. So Python generator.py. Okay, it did this. I'm going to print reverse called. Okay, it is called just once, like I suspected. And it's basically, I think Python is doing something as a wrapper. And when you call this, it detects that this is what's happening. It's not returning anything, but it looks like it's internally returning an iterator. And it is happening because of this yield statement. That iterator is internally calling this stuff. It's not calling the method, but it's calling this thing, which is super weird, which is super duper weird. All right, so here's what I'm going to do. I'm going to yield 1, yield 2, yield 100. Okay, it's basically ignoring whatever data I pass in. When I loop through, I expect these three values, 1, 2, and 100 to be printed. Okay, so it works fine. So basically, it's, I guess I have to stop thinking about it because it's implementation detail. But the way I've understood it is, every time it does a yield, it's um, it's kind of like a proxy for when next is called, because I'm assuming this is still calling, it's still using the iterator pattern, right? This guy doesn't know that what's happening there is a generator, right? This guy still thinks it's an iterator. So Python is somewhere getting in between and converting this thing from a generator to an iterator. I guess when it does it is probably not something we should worry about. So I'm going to stop worrying about it. How about that? Anything that can be done with generators can also be done with class-based iterators, as described in the previous section. What makes generators so compact is that the iter and next methods are created automatically. Well, there we go. Yeah, it's automatically constructing that object and creating it for you. Another key feature is that the local variables in execution state are automatically saved between calls. This made the function easier to write and much more clear than an approach using instance variables like self.index and self.data. In addition to automatic method creation and saving program state, when generators terminate, they automatically raise stop iteration. In combination, these features make it easy to create iterators with no more effort than writing a regular function. Yeah, quite like it. I do like it. It's basically like you don't worry about the next and the iterator and all that stuff. All you're doing is you want to return a bunch of values. You just get to each value and stick a yield in front of it. And you know that Python is going to submit the right value when it is called by by the iterator, right? So it's like kind of abstracts it out. You can almost imagine that that's the whole thing is happening inside one method, even though it's multiple calls. You don't have to worry about the multiple calls. Fair enough. Again, it's very similar to JavaScript iterators. Some simple generators can be coded succinctly as expressions using syntax similar to list. Oh, can I use yield for what was it called? The what's that expression? I keep forgetting. I keep forgetting. Comprehension, list comprehension. Can I use yield with list comprehension? I don't know. Well, let's see. We'll get there. Some simple generators can be it's right here. Some simple generators can be coded succinctly as expressions using a syntax similar to list comprehension, but with parentheses instead of square brackets. Okay, that's exactly what I was thinking of, but it's a different syntax. So you have parentheses and sum of squares, sum of I times I. Ah, okay, interesting. Generate these expressions are designed for situations where the generator is used right away by an enclosing function. Generator expressions are more compact but less versatile than full generator definitions and tend to be more memory friendly than equivalent list comprehensions. I guess it's memory friendly because it's not actually converting those values. It's more of like an expression that gets evaluated at runtime. So it makes sense that it is more memory friendly. Why is it called generators? It's called generators because it's actually generating values. It's not like you're iterating over a list. You're every call is actually invoking an expression to be executed, right? Like what we saw here, this one's a list right now, but this doesn't have to be. We did yield 1, yield 2, okay? And this works fine. So this is basically you're writing code which is generating each value that is eventually going to get called by an iterator. That's the reason why it's a generator. The way you generate value can be anything. Here it happens to be from a list. It could be something else. You could make an HTTP call every time and generate it. At least that's how it is in JavaScript. I don't know how async works in Python, but that's the reason why it's called a generator in the first place, right? It's like it's programmatic code. You're not looking at data. You're writing code that emits a value each time. Okay, because Python. Yeah, sure. Biggest Python. To be fair to Python, though, it's generator is a name that maybe precedes Python. A lot of other languages have it. Does Kotlin have generators, guys? You have a bunch of Kotlin fanboys here. What do you think? Do Kotlin have generators? All right. I'm gonna try this out. So let's say I have this. This is like a list, and now I want to have an iterator which does, let's see, um, double the elements in the list. Okay, so I'm going to say for val in parentheses x times 2 for x in s, print of val. Okay, so this worked fine. I'm gonna have to put this back, sorry. I was showing that as an illustration. Okay, so this is one way to print. There's one way to print the values by using this reverse, but this is something that we're doing right there, right? We are, oops, I removed what was in the clipboard. So for val in, you're basically doing x times 2 for x in s, print val. This will print double numbers. So you're kind of calculating this on the fly, and you're using an expression for it. So this is equivalent to the list comprehension expression, but we're doing this on the fly. And you can, this is kind of like a map, but I guess this could work this way as well, right? This will work as well, like proper list comprehension. This will work as well. Now, what's the difference? The difference is with list comprehension, you are converting each value in place and then looping over it. But with generators, what you're doing is you're leaving it as is. There is a programmatic construct which pulls an element from S each time. There is no duplicate element. Space complexity is not double now, right? With list comprehension, space complexity is double. Now there is a new list which has all the double values and then you're iterating over it. But with the generator, you don't have two lists. It's the same list, but each time it's asking for a next. It's pulling up the value, doubling it, managing the index internally, and then returning the value. So its space complexity is going to be just O of n in this case. Does that make sense? Okay. Will yield block the main thread? Yes, right now it does. It is all synchronous right now. Everything is synchronous. We're not dealing with asynchronous. Okay, here are some examples. We have two lists. Sum of x times y for x comma y in zip. Okay, again, they're doing a zip, getting both the values, x and y, key and value, or individual values here. Not This is not a dict. So they're zipping this up. They're getting both these things, and then they're multiplying. There's a very elegant way of doing this, right? Multiplying two lists. Unique words. Set of word for line and page for word in line of split. What? Okay, this needs some parsing. For word in line dot split. For a line in page. Okay, this is blowing my mind right now, and I have no idea what this is doing. If you guys know what this is, let me know. This is like, I think there are two comprehensions. Generator comprehension. What is this? What comprehension is this called? This one's list comprehension. What comprehension is this? Generator expressions. Okay, these are called generator expressions. Peak Python moment. Yes, yes. You got to be you're a true Python programmer if you don't think of this as a peak Python moment, right? This is a peak Python moment for us because we are noobs. Once we become experts, this is the Pythonic way, right? The way you treat these moments change. It's all a matter of perspective, my friend. Okay, so okay, so we have forward in. Okay, I think we have to read this from the right. Isn't that right? So we have line dot split. So we are basically splitting the line. Oh no 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 no! For this one, for line, I think it has to start from here. For line and page. Okay, I'm guessing page is a document or like a bunch of lines. So it's taking each line. Okay, for a line and page, word for word in line dot split. So it's going to take each line and then for each word in the line dot split. So it's gonna do line dot split. Now it's gonna get each word in that thing, and now it's gonna get the word. Okay, those are the levels. Okay, so for line and page to get an individual line, and then for word and line dot split to get the individual word, and then it's going to get the word out. So it's going to yield the word out. Now we have individual words in the all the lines. Now it's putting it into a set. So you're going to get unique words from the document. All right. I think I'll take a break after this one. It's this one's I don't know if I'm ready for I don't know if my brain is ready for this line of code. Okay. I don't think I'm ready. This is high IQ stuff, guys. I don't think I have enough IQ to parse this thing. I'm struggling with this stuff. Okay. Um, Max GP. Yeah, I understood that. The question is, how does it do it? Like, what is the order in which it does it? So I think I figured out the order. The order is first it goes the first it does this, okay, and then now it gets the line, and now it does line dot split of that, and then gets the this is the for word, and then it this is the word that gets yielded, okay, and then putting into a set is simple after that. But yeah, it takes a while. Like, how do you parse this? How do you know what happens first and then what? Like, if you have a nested loop, you know that the outer loop executes first, right? Now, what is the equivalent of that here? That's um, that's the part that I was like struggling a little bit. Okay, so this one seems simple. For student in graduates, max of student GPA, student name. Okay, seems simple enough. So this is emitting student GPA and student name, and it is doing a max of student GPA comma student name. So it's like, I guess, sorting by student GPA first and then sorting by name. Is that what this is doing? Maybe. Data equals golf for list of data of I for I in range of, again, this is range in reverse order, length to -1 in -1 increments, which is basically one decrement. It's getting data of I, so it's getting each letter one by one, and it's putting it into a list. So we have a list of all the letters reversed. That one is simple. More math way of working with collections. I think so. It's more of expression based, which takes a little bit of wrapping your head around. It's more declarative than imperative. I think with Java, we're more used to imperative. The most we do with declarative is basically using functional programming with collection APIs, right? Stream APIs. This seems to have taken it to one level above. Okay, so we've got this, and let's see what's next. Next is a standard library. I think I'm going to I think I'm going to take a break here. Ask ChatGPT to do it. Yeah, yeah, it is. It is actually true. It would probably give a better explanation. So I'm probably going to use ChatGPT a lot more in these live streams from the next stream onwards. All right. So I think what here's a plan for the next stream. Okay, we have done a couple of hours. I'm going to take a break now. Next stream, I'm going to set this up. So make sure you ring the bell, guys. Ring the bell. By bell, the channel bell needs some ringing. Right? Not enough people are ringing it. So go ring it. When I schedule a live stream, when I go to a live stream, you will get a notification so you can join, or at least even if you don't want to join right then, right? You will know that I've streamed, so you can go check the recordings later, right? You will see these peak Python moments, and you don't want to miss that. Go ring the bell, wait for the next stream. In the next stream, here is the plan. I'm going to ask ChatGPT to create some exercises. Okay, I'm going to ask it to give exercises. Yeah, hallucinated code. Like, I do enough hallucination myself. I don't need ChatGPT to hallucinate for me. I'm going to ask ChatGPT to give me exercises, and if the exercise seems wonky, I will know. Right? I'm going to ask it to give me problems that cover classes, interfaces. It's not interfaces. Classes and inheritance. Does Python have interfaces? I'm going to ask it to do classes and inheritance, and iterators and generators. I will ask it to give me some exercises, and I will do those exercises, and you do those with me in the next session, right? Open your editors, do this with me, finish ahead of me, and tell me how much better you are than me. Okay, I want to hear that. It's going to do wonders for my ego. But just kidding. Do that, and join me in the next session. Okay, we're going to write some code to test out our understanding, and then we're going to get into the standard library. This is where we get to use the APIs that come out of the box with Python, and then we get to play with it and do some more advanced stuff. Thank you all for joining. I am happy to stick around for maybe like 10-15 minutes more. If you have questions, you can feel free to ask me any questions which are not related to Python, and and then we can and then we can disperse. Don't forget to put AI and chat GPT tags. Oh yeah, oh yeah. If you want views, you have to put chat GPT in. You have to put chat GPT tags. You have to put an evil looking robot in the thumbnail, because that's what people are scared of, right? They're scared of evil looking robots taking over their jobs. So you got to put that in the thumbnail, and you got to put something like, is this the end of programming? That's a viral video right there, my friends. I'm going to tell you. I should probably make a video about that, right? Is it the end of programming? Evil chat GPT robot, and maybe a programmer like me sitting and crying in the corner. That's the video I need to make. Look at what I'm doing. I'm actually learning stuff. Who wants that? It's all over the place, isn't it? Like, I see. I don't know if it's because I'm interested in AI and like I'm trying to learn, but it's hard to distinguish the good stuff from all the fluff. It seems like all the people who are talking about Bitcoin and blockchain and Web 3.0, all those folks have now moved to AI. They're doing the same crap with this, right? They overhyped Bitcoin, they overhyped crypto, and now they're overhyping um, AI and Chat GPT. It's like they just need something to hype. It's unfortunate. It's unfortunate. It makes my job as a YouTube content creator difficult. Like, do I yield in and make such nonsense videos? I'm holding back. I'm trying not to make it. OBS 90% sure. I don't know what that means. What does OBS 90% sure means? I don't know. Explain, please. Give me an online AI hackathon, Java Brains. I feel like once we have some Python knowledge, I need to have Python knowledge. Once we have some amount of Python knowledge, create uh we can create like a microservice where you do some stuff in like a regular, deterministic coding in Java or JavaScript, and then we can offload some parts of the application to AI and kind of enhance the application itself. That can be a really cool thing, right? Imagine creating like a chatbot or something like that, where you do some stuff in Java and just the AI part in JavaScript. Yeah, a lot of opportunities, lot of opportunities. Kafka and Liquibase, no, I don't have any videos of that so far. No. Game development in Java, I believe I did. This is long back. I did the Snake game in Java, but none of the new stuff, right? I know there's Unity integration. You can actually build Unity apps with Java. There are a bunch of other game libraries in Java. I'm not quite sure what the best ones are. Java really doesn't make a good use case for games. Um, I know everybody talks about Minecraft. Like, Minecraft was built in Java, but it's one. Okay, so I don't know much about game development in Java. I'll be very honest. Sam Altman and Elon Musk to judge the hackathon. Yeah, so Core Labs Pro. I will set up the hackathon. You go invite them, okay? So I'm sure you have their contacts and all that stuff. So just hit them up on social networks. Ask them to come judge the hackathon. I'll take care of the other stuff. Great suggestion. Let me know when you have them on board, okay? libgdx. Yeah, I've heard some of these. I've heard of libgdx. I don't know what LWJGF is. Uh, I think isn't the easiest way to use something like Unity, and isn't there like a client for Unity in Java? Why not use that instead of using OpenGL? I think Unity provides a little more um, better APIs, which does what you would otherwise have to do with OpenGL. Again, I'm not very well versed in this thing, so take my suggestion with a grain of salt. You probably know better. Have you tried using Unity? Okay. Yeah, I've never tried this. I feel like it's still very much relevant, and people use it mainly because these kind of things take time to die. Like even if somebody were to be like, let's switch off of Java today, it's going to take a lot of time for everybody to move, and there is a little bit of a self-fulfilling prophecy. There's a little bit of an inertia with these kind of things. You can, if you're a big company, you can of course create a new product by using Golang, but then you're going to have a much easier job with hiring people and keeping people if you have um, if you've written it in Java. So it takes a while for the whole thing to shift. Okay, so companies use Java because there are developers writing Java, and developers are learning Java because there are companies that use Java. It's kind of like that virtuous cycle. This will obviously change, of course, as something new comes in, and as the momentum builds, it is going to change. But there has to be a certain tipping point for that to happen. Is Golang there close enough so that it can tip Java away? I don't know. I don't think so. I don't think so. It's still like there are people who are enthusiastic about it, but I don't think it's there. It's strong enough to tip over Java, where Java is popular right now, which is in the enterprise application space, in the web development space. Um, there are other areas that might come up which require these languages. Like for example, Python is so strong right now because of data science and AI. Kotlin is strong right now because of Android development, but none of them have kind of encroached Java's territory. They've just basically created new areas of their own. So honestly, I don't see in the next 3 to 5 years. But then also with the rate at which AI development is happening, I don't see how programming is going to evolve in 3 to 5 years. The like I have a bunch of thoughts about AI that I want to make a video on and share. No scary robot, no, our jobs are going to go away. It's more of like how does this manifest in the future? Like what would programming look like 3 to 5 years from now? I feel like a lot the biggest change that will happen is what we consider as a substantial output for a programmer in a day's job. Okay, so we think about like, okay, you want to build a Java module, you need 2 days for it, right? Or you want to build a controller, it takes like 4 or 5 hours for it, something like that. You have a kind of an estimate of how long it takes to complete a certain task depending on the perceived complexity of the task. That is going to get blown away, right? That's going to be very different now. It is going to be um, higher expectation on a programmer to deliver much faster because of the tools that help us. Okay, if you in 3 years from now, if you say it's going to take me 2 days to build a simple microservice, they're going to be like, no, you can do it in 3 hours, right? So that is going to shrink. And also, as a result, application development will probably change so that we are doing a lot more. One of the reasons why so right now there is a lot of thought that is given to, okay, let's figure out what to build first, and then you spend some time figuring that out, and then you go and build it. Why? Because building that thing is expensive, right? You have to put developers, they have to manually build the thing. But with AI assisted development, since that part becomes easy, there's going to be less focus on trying to figure out the right thing to do upfront. People can be like, okay, we have 3 ideas, we don't know what works, let's build 3 different applications. It becomes a valid and feasible prospect because AI is assisting us in development, right? So we'll probably end up writing more code. That's the perspective that I see. It's not like AI is going to take over our jobs. Our code output is going to be more, and our thought process behind what a development process is going to be more. It's going to be changed. So that's what I think. So I think that's what's going to change. If things remain as is, I don't think it's a language specific thing. It's more of like how we approach development itself, which is changing. I don't see Java going away in 3 to 5 years. Solo devs can build entire tech stacks. Well, solo devs can build faster. I don't think they can build broader. That's a little, I don't know, with the way things are right now, I don't think AI is assisting enough in the breadth. It's more of like, you know, a certain task, you want to do it, it makes you do that faster. So I don't quite know if we're going to get, maybe we get there in the future, but I don't think we're there yet. Okay. Best job will be a researcher and scientist. I don't know. I don't know. This could go away too. And even if that remains, it's going to be a very small subset of people who are going to be working on this. So imagine you train a new LLM, right, which is code aware, it does Python stuff. How many people are needed for it? That LLM could potentially be used to assist thousands of developers, but how many researchers do you need to build that LLM? So what's going to end up happening is, if you pick a researcher job, you have to be at the top of the top because there's only few people who are going to be working on it. So if you want to do that, sure. But if you don't want to do that, then I don't think that's the best job. The best job is the job where there is enough demand and enough supply, right? You need a healthy demand and supply. If you have less demand and more supply, you're out of a job. If you have less supply and more demand, again, you need to be the top of the top, which is what the research scientists are going to be over time. You need to pick something which has a healthy balance, and that's where you can lead a fairly comfortable life and also have a decent amount of career progression and earning and all that stuff. That's what I think. We need to know what we are doing and how to do it to use AI to max, because then it can type 10 times faster. You don't need to write a lot of boilerplate stuff. That's true. That's true. You need to kind of know, it's very localized right now. AI help is very localized. You can't say, build me a microservice which does A, B, and C, right? You're built a microservice and you're like, I have a method here. Build me a method which accepts this as an argument and return. See, that's the level at which AI is in right now. Um, if it gets to a point where it can take in so much context, then maybe it can get there. And if you hook it to something like an auto GPT where it can actually go create stuff, run terminal commands and all that stuff, maybe we can get there. But we're definitely not there now. All jobs in the future will have job title prompt engineering. I don't think there's going to be a job anymore. That's going to be what we do all the time. Okay. It's like saying I'm good at writing CLI commands. Well, no, you're a programmer. You have to write CLI commands, right? So I feel like prompt engineering is going to go away from this small subset of people who are really good at it to a skill that we all need to have. It's going to be, working with AI is going to be a skill like working with Microsoft Word or working with a terminal or writing shell commands. It's going to be an essential skill. It's not going to be a prompt engineer job anymore, is what I feel. The Java install base is very big, and move enterprise application to a new language is very costly and risky. That is true. That is true. Existing applications will remain. The question is what happens to new applications, because that's what's going to affect 5 years from now, right? If you're looking at 5 years from now, um, a new, like a big enterprise, they want to build a new application. What is their go-to language of choice? Right now their go-to language of choice is still Java because developers are still on Java, right? And Python sucks with performance. You don't you don't want to build, like, if you're an architect, you're not going to be building a Python microservice to serve huge scalable applications and microservices. You're still going to use Java. So yeah, that's the reason. Well, a bunch of reasons why Java is still the top pick for new enterprise applications now. What do I need to learn more to get a job? Well, it depends on what you already know. How can I tell you without knowing what you already know? Java 8 to Java 9, yeah, yeah, that's a problem. And Java is moving pretty fast now, so they're adapting to changes. It's not your grandmother's Java anymore. They keep new releases all the time. Numbers are flying, like version numbers are like, they constantly keep coming up with new stuff. So that's exciting. All humans are CLI engineers. If you think of prompt engineering as a thing, right now we are CLI and IDE engineers. Think about it that way. Imagine calling somebody, are you an IDE engineer? You're writing code in the IDE. No, your IDE is a means to an end. Similarly, AI prompts eventually are going to be an essential means to an end. They don't care that you're prompting AI or whatever, they just want the job done. And people are going to talk about, I use, like right now, people are going to talk about, okay, is IntelliJ better or is VS Code better? People in the future are going to talk about, hey, I use this language model to generate this stuff. Hey, I use this other one. That's going to be, it's basically a tool in the tool chain that people are going to use. And it's not going to be like a specialist prompt engineering thing. People are doing that now because nobody knows how to do prompt engineering, right? They're figuring it out. So they're doing the work that we're going to leverage in the future. And in the future, their job is going to be gone. It's going to be everybody. At least that's what I think. Which best app? Python and Android Studio. I have no idea what you're asking there. One is not the same as the other. So I don't know. Maybe rephrase the question, please. What do I need to learn to get a job? I know Java, Go, Linux, C, backend, microservices. I made projects about networking. Well, you have enough to get a job. Get a job where people are doing this. This is a good set of skill sets, right? You can you can technically get a job from this. I can make backend if you tell me what it does, but I don't have self motivation to make a site. Well, you don't have to make a site. You just get a job. They will pay you to make it. That's going to be your motivation. All right. I'm going to wrap up now. It's been a while. Thank you again for joining me on this stream. I hope you found value from it. This today was an interesting one. We learned about inheritance, multiple inheritance, which is a bit of a mind bender, and we learned about iterators and generators, and we created them as well. Um, Now, what I'm going to do is I'm going to first check in this code so that you can pull it out. So we have session 6. So this is going to be end of session 6. This is the state of the code. I have posted this in the, well, it didn't add everything, did it? Okay, commit, commit staged amend. Okay, so I've pushed all the changes. Make sure you get it and play around with it, and we can. I'll see you folks in the next live stream. Ring the bell. Ring the bell. You will know when I'm there. Thank you so much for joining. I'll try and have some time uh, devoted for the next um, stream as well. I know this is. I just want to highlight this part. Yes, it is kind of weird that you have to learn a whole lot of stuff while you're in college when your eventual goal is to become a programmer and you're not going to use any of that. I have a lot of opinions about education in general, and I feel like it could be better. But one of the things that you'd learn when you're learning chemistry and physics, even though you're never going to be using it, is you're going to learn how to learn. Okay, you might, for example, become a programmer, get a job in a biotech company, and you're going to have to learn that domain. Okay, it's not related to programming at all. A lot of developers, a lot of software engineers learn things which are totally orthogonal to their field because they happen to build applications that serve that field. So trust me, when you get to that point, when you're working on something and they use a term, you go like, okay, I know about this. You may not realize that this was something that you learned back in college, but those things do come up. And even if something doesn't come up, you know that that's you have learned how to learn. So learning about this is going to teach you how to learn so that you can apply those skills and learn over there. So don't be optimizing your learning experience. Learn as much as you can. Okay, learn as much as you can, and in this case you're expected to learn, so learn as much as you can. You can optimize what you want to choose and retain or use or whatever, but you given the time, you're given the resources, you're not saving anything by not learning. Okay, so go ahead and go full focus and learn it. That's the best advice I can give you. um, Go and sleep. I'm guessing that's the advice to the 17-year-old. You're past your bedtime. Go and sleep. I think whoever is dialing in from India, the other side of the world, it is time for you all to go and sleep, I guess. So the other parts of the world, hope you have a nice day. Thank you for joining. See you later.